Science is the answer to all the questions in your mind, full of fun and learnings here you can find. Get ready for the blast, explosion of knowledge here at last. Science and technology, sing along with energy. 1, 2, 3, let's go! Chemistry, biology, physics and ecology, geology, meteorology, and astronomy. Many more branches you can explore. So come and join us in the world of science. Whoa, oh, whoa, oh, oh. Whoa, oh, whoa, oh, oh. So come and join us in the world of science. Yeah! Whoa, oh, whoa, oh, oh. Whoa, oh, whoa, oh, oh. Whoa, oh.
Hello there, Scienatics! Good day! Welcome to a fun and exciting lesson with me, Teacher J. I love hula hooping. It's my way to shed some sweat, especially this time of pandemic where we need to get fit and healthy. I love to spin this hula hoop around my waist as I spin around the chair. In this lesson, we will talk about rotation from revolution. Today, you will learn to differentiate rotation from revolution and describe the effect of the Earth's motion. Are you ready to explore? Great! You have learned from your previous lesson that Philippines has two distinct seasons in relation to physical and geographical location on Earth. This time, you will learn the different Earth's motion in relation to day and night, sequence of seasons of countries on Earth, and the effects of Earth's motion. Do you know what the Earth is made of? You are right. The Earth is made up of rocks, soil, water, and air. It is one of the planets that spins and travels around the sun. The Earth is a very tiny part of the universe but home to many forms of life. The Earth moves at a constant motion. Basically, the motion of the Earth can be classified into two ways: rotation and revolution. Every day, the suns appear to rise in the east, travel across the sky, and sets in the west. You can observe this day in and day out. But the sun does not move from east to west. Instead, the Earth is spinning on its axis. What is an axis? Imagine a line that passing through the center of the Earth that goes both the North Pole and the South Pole. We call that invisible line the axis. This spinning movement is called Earth's rotation. And this Earth's rotation is what gives us, you've guessed it right, day and night. One complete rotation of the Earth makes up one complete day, with day and night happening within 24 hours. The sun is the closest star to Earth. The sun seems to rise in the east and sets in the west. The apparent movement of the sun is due to the direction of Earth's rotation. This rotation of Earth causes day and night. If you're on the side of the Earth that is facing away from the sun, as the Earth is spinning, it's night. If you're on the side facing the sun, you are correct. It's day. Now, look closely.
The illustration shows the sunlight, as represented by the arrows in the figure, receives by the Earth on some of its parts, making it daytime, for these parts facing the sun. On the other hand, the figure also shows that as the Earth rotates, the other side of the Earth do not receive sunlight, making it nighttime on this part of the Earth that are not receiving direct sunlight.
Hold on tight because the Earth is actually moving in more ways than one. At the same time the Earth spins on its axis, it also orbits or revolves around the Sun. This movement is called revolution. The Earth is rotating on its axis, creating day and night. At the same time, it's revolving all the way around the Sun. As the Earth is both rotating and revolving around the Sun, it is not sitting straight up and down. The Earth is tilted on its axis. Can you guess how many degrees the Earth is tilted on its axis? Yes, correct. Its axis is tilted by 23.5 degrees, and its tilt causes one part of the Earth to lean towards the Sun while the another part is leaning away. This means that the different parts of our planet's surface gets different amount of sunlight and heat.
The northern hemisphere experiences summer, while the southern hemisphere experiences winter. In half a year, the Earth will revolve elliptically counterclockwise around the Sun while it's tilted 23.5 degrees. When the axis tilts away from the Sun, the northern hemisphere then experiences winter and the southern hemisphere experiences summer.
So why am I telling you this? Well, as the Earth revolves around the Sun, it creates a pattern throughout the year. This pattern happens over and over again. At certain times of the year, you see the northern hemisphere leans towards the Sun and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the Sun and the northern hemisphere leans away. That pattern, my dear synaptics, is what makes seasons. It takes 365 and 1/4 days or 1 year for the Earth to complete one revolution around the Sun. In some countries, this movement of the Earth causes 4 seasons. What are those seasons? Summer, autumn, winter, and spring. Good job, synaptics! Summer begins in the northern hemisphere on June 21. During this time, the North Pole is tilted to its full 23.5 degrees towards the Sun. During this time, the northern hemisphere experiences its longest daylight period. What do you think the southern hemisphere experiences at the same time? You've guessed it right. The southern hemisphere experiences the shortest daylight.
Autumn starts in the northern hemisphere on September 21. During this time, the sun is over the equator, and the axis of the Earth is neither tilted toward nor away from the sun. Also, on September 21, the length of day and night are again of equal length. It is called autumnal equinox. Winter starts on December 21. At this time, the North Pole is tilted to its full 23.5 degrees away from the sun. The longest daylight occurs in southern hemisphere, while the shortest daylight period occurs in northern hemisphere. Spring begins on March 21 in the northern hemisphere. During this time, the sun is over the equator, and the Earth's axis is neither tilted toward nor away from the sun. On March 21, the length of day and night is equal. This is called spring equinox.
Let's do a simple demonstration. You will be needing a globe, a bulb, and a table to put them both on. Put the bulb in the center of the table and turn it on. Put the globe in the side of the table. The globe is Earth. The bulb at the center of the table is the sun. Now slowly spin the globe as the Earth rotates. The sun lights up in one side of the planet. It's day where the light is shining more brightly on the globe, and night where it's not. Now let's see what's the Earth's revolution look like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun with other hand. So do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 and 1/4 days rotation, and that's another year gone by.
What are your science key takeaway for today? Great! The two motions of the Earth are rotation and revolution. What is Earth's rotation? Correct! Earth's rotation or Earth spin is the rotation of planet Earth around its own axis. One complete rotation of the Earth makes one complete day, with day and night happening within 24 hours. How about Earth's revolution? Very good! The movement of the Earth around the Sun in a fixed path is called revolution. The Earth revolves around the Sun from west to east or counterclockwise direction. The Earth completes the revolution around the Sun in 1 year or precisely in 365 and 1/4 days. So what causes seasons? Great! Seasons are caused by Earth's tilt on its axis as it revolves around the Sun on its orbit. When one hemisphere gets more direct sunlight, it's summer. Temperatures are warmer, days are longer, nights are shorter. How about during winter? Correct! When it's get more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, nights are longer. Good job, Synaptics! Bring out your pen and paper and let's have some assessment. Do you now have your pen and paper with you? Let's start. 1. What do you call the imaginary line where the Earth rotates? A. Axis, B. Equator, C. Rotation, D. Revolution. Correct! A. Axis. 2. How does the Earth rotate on its axis? A. Clockwise direction, B. From North Pole to South Pole, C. It spins and stops and spins again, D. Counterclockwise direction. Very good. D. Counterclockwise direction. 3. How long does it take the Earth to make one complete rotation? A. 14 days. B. 12 days. C. 24 hours. D. 24 days. C. 24 hours. Correct. 4. Which of the following explains the cause of day and night? A. The revolution of the Earth around the Sun. B. The rotation of the Earth around its axis. C. The rotation of the Earth around the Sun. D. Both A and B. You've got it right again. B. The rotation of the Earth around its axis. 5. Which of the following statements tell about Earth's revolution? Statement 1. Revolution of the Earth takes 24 hours. Statement 2. Revolution is the movement that causes day and night. Statement 3. Revolution of the Earth takes 365 and 1/4 days. Statement 4. Revolution of the Earth is when Earth orbits around the Sun. A. Statement 1 only. B. Statement 3 only. C. Statement 2 and 4. D. Statement 3 and 4. Excellent! D. Statement 3 and 4. Congratulations, Synatics! You were able to answer the assessment correctly. Good job! That's all for today. I hope you have learned something new. Remember, science is fun. Science is exciting. Keep on thinking, keep on exploring, keep on learning. Again, this is Teacher Jet, your science teacher. See you in our next class. Bye!
Science is the answer to all the questions in your mind, full of fun and learnings here you can find. Get ready for the blast, explosion of knowledge here at last. Science and technology, sing along with energy. 1, 2, 3, let's go! Chemistry, biology, physics and ecology, geology, meteorology, and astronomy. Many more branches you can explore. So come and join us in the world of science. Whoa, oh, whoa, oh, oh. Whoa, oh, whoa, oh, oh. So come and join us in the world of science.